Good morning, my dear students. Welcome to online video lecture. Today we are going to discuss the chapter that is transportation model. These are the contents of this video lecture. Today we are going to discuss the definition of the transportation model and how to formulate the transportation model and how to find out the transportation cost, that we can call it as optimum solutions, and what are the methods that we are going to follow to find out the optimum solution. Those methods we are going to discuss here, and among those methods the one first method is northwest corner rule. As you know that the transportation model is one of the operational research technique that is used for to reduce the transportation cost. That means while the transporting the quantities from one source to the another destination, whatever it may be the transportation cost, that transportation cost is going to be reduced. Okay, determining the minimum transportation cost of the quantities transporting from one source to the other destinations that we can done by this technique. And this is the basic structure of the transportation models. Columns are represented by the destinations and rows are represented by the sources, and supply, those are represented by I1, I2, I3, I4, and demands are represented by J1, J2, J3, J4, like this. I1 supply center, that is I1 is represented by, that is the quantity is available at the source 1, that is I1. I2 is the quantity is available at the source 2, that is I2. I3 is the quantity is available at the source 3, like this. And demand, when it comes to demand J1, J2, J3, J1 means the quantities are required by the destination 1, that is J1. The quantities are required by the destination 2, that is J2. And quantities are required by the destination 3, that is J3. Remember, I1, I2, I3, I4, these are represented by the rows, these are the supplies, the quantities are available at the different sources, and J1, J2, J3 are the quantities are required by the destinations. Okay, now C11, C12, C13, these are all C terms that you can call it as transportation cost. That means C11 means the unit of shipping cost from first source to first destination, that is C11. C12 means the unit of shipping cost from first source to second destination, that is C12. C13 means the unit of shipping cost from one source to third destination is C13. Okay, all C terms that you can call it as transportation cost. Next, come to the X terms. X11, X12, X13. These are all you can call it as quantities. That means that who are the quantities shipped from first source to first destination, that is represented by X111. Remember, the X terms are all you can call it as quantities, C terms that you can call it as transportation cost. Now, find outing the transportation cost is itself you can call it as optimum solutions. What we are going to find out the transportation cost, that we can call it as initial feasible solution. That means that we are going to solve the transportation problem with two steps. In the first step is that we are going to find out the transportation cost, that we can call it as initial basic feasible solution. And in the second step, what we have find out the initial basic feasible solution, whether it is optimum solution or not, that we are going to find out by the carrying the optimality tests, that is modified distribution test. Remember that you are going to solve the transportation problem with the two steps. In the first step, that you can find out the transportation cost, that we can call it as initial basic feasible solution, and in the second step, that you are going to carry the optimality test, whether the initial basic feasible solution is optimum solution or not, whether it is the minimum transportation cost or not, that you are going to find out by carrying that optimality test with the method of modified distribution test. Now, these are the different methods to find out the initial basic feasible solution. The first method is northwest corner method, and second method is lowest cost entry method, and third one is Ozel's approximation method. Today we are going to discuss the northwest corner rule. Okay, this is the method very easiest and systematic method to find out the basic feasible solution. These are the steps you need to follow to solve the transportation problem by using northwest corner. The first step is construct an empty m into n matrix completed with rows and columns. M means here the rows and n are columns. Step 2, indicate the rows and column total at the end. That means number of rows are represented by m and number of columns are represented by n. And in the third step, you need to start the allocation process from the northwest corner cell. That is starting with 1 cell, upper extreme left cell, that we can call it as northwest corner cell. And in step 4, step 5, step 6, step 7, step 8, that we are going to discuss in the further slide while solving the problem. This is the first problem, transportation problem, that you can solve this problem by using northwest corner cell. See here, in this problem they are given the warehouse plants. How many warehouse centers are there? W1, W2, W3. These are, you can call it as destination centers. And plant P1, P2, P3. These are the all, you can call it as sources. P1, P2, P3. Destination centers are W1, W2, W3. Sources are P1, P2, P3. Now in the supplies they are given 20, 28, 17. 20 means the quantity is available at the source P1. Sub 28 means the quantity is available at the source P2, like this. And he has also given the demand 21, 25, 19. 21 means the quantity is required by the warehouse, that is W1. 25, the quantity is required by the W2, like this. Now the first step is that whether the given problem is balanced or not. How we are going to find out? We can add all the supplies and demand. If it is both are equal, then the problem is balanced. See, if you add the supply 20 plus 28 plus 17 will get 65, and we add the demand, that is 21 plus 25 plus 19, that is also 65. Here it is the supply is equals to the demand, the problem is balanced. Next, step 2, you need to start the allocation process. Now this is very important here. Then you need to start the allocation process from the northwest corner cell. Northwest corner cell means upper extreme left cell, you can call it as northwest corner cell. Here northwest corner cell is P1, W1, that we can call it as northwest corner cell, that is 7 is there. Okay, now in that the P1 and W1, in the first row P1 the supply is how much? 20 is there. and demand for the W1 it is 21 is there. Which one is the minimum here? The supply is the minimum, so that we can allocate the 20 to the northwest corner cell. That is, we are allocated 20 to the cell, that is P1 W1 cell, that you allocated 20. Now the supply is fulfilled. Now delete the P1 row. In the, see the, in the demand wise, here it is 21 is there, we have already allocated 20, and here in the demand it is left with 1. Okay. Now in the second step, the same process we can continue here. We can delete the first row, that is P1 row, because we have fulfilled the supply 20, in the demand it is left with 1. Now in the second step, again we can start the allocation process. We have deleted already P1 row, and now it comes to the P2, and W1 is the northwest corner cell. Okay, here the upper extreme left cell, that is we can call it as northwest corner cell, that is P2 W1. Now for this cell, see the supply how much it is there, 28, and see the demand, it is left with 1. Okay, that we have did in the previous step. Okay, it is left with 1. Now which one is the minimum, 28 or 1? The demand is 1, so that 1 is the minimum, so that we can allocate it 1 to the cell P2 W1. Now the demand is fulfilled, and remove the column, that is W1 column, we can delete the column. And now in the supply we have allocated 1, so that in the supply it is left with 27. 28 minus 1, who are among the 28 we can allocated 1, so that in the supply it is left with 27. In this manner we can continue the allocation process until we will satisfy the supply and demand is fulfilled. Now same at the end, that we are getting the after the allocations, that we are getting the this one, there is a one formula is there, number of allocations equals to the number of rows and number of columns minus 1. Okay, number of allocations. Now can you tell me how many number of allocations are there here? Allocation cells, there are 5. Okay, and number of rows number of rows P1 P2 P3, number of rows are 3, plus number of columns 3, W1 W2 W3, 3 plus 3 6 minus 1 it is 5. Number of allocations are 5, and also number of rows plus number of columns minus 1, that will gives also 5. Okay, now how we are going to find out the transportation cost means, only we can consider the allocation cells that were carried in the previous step, that is, see the consider allocation cells, that is P1 to W1, that is 7 into 20, that will gives 140. Then P2 W2, 5 into 1, that is 5, that will gives the 5. And P2 to W2, that is 7 into 25, 175. Only we can consider the allocation cells, and that will, after multiplying those cells, after adding those cost, that will give the total amount is 462. Okay, this is the transportation cost that you have found out by the using the northwest corner cell. Thank you.